Do you want the examples to all be chemistry related?
No, they don't have to. Matter of fact, I'd like you to find some that are kind of unusual or different. That would be fine. You got a couple minutes left, ladies and gentlemen.
Oh, chicken. Myself in the bag. Okay. They would give it like elements and stuff. It's so kind of equation.
Mr. Burns, crazy. We only have 14 more days left of school.
It is getting down there. It is getting down there. So. I normally don't start counting till we're under 10.
I don't think I ever had you in third trimester before.
Well, the only other class you would have had me in would have been physical science. And 2 out of 3 chances that was in the first or second try.
First try.
Oh. All right, somebody give me a good definition of a redox reaction.
Chemical reaction that involves the transfer of electrons between 2 species.
That is absolutely perfect, ladies and gentlemen. That is the definition of a redox reaction that we're going to use in this class. A chemical reaction that involves the transfer of electrons between 2 species. So for that to happen, ladies and gentlemen, one element needs to give up electrons and the other one needs to gain. Okay? So that's what happens, which means something is not charged and becomes charged, or something that is charged becomes stable. Okay? It can happen either way. We'll get into showing you about that. All right, now give me a common redox reaction. Go ahead, Zoe.
I found this color displayed in fireworks.
Okay? The fireworks is a redox reaction. In other words, when fireworks go up and they explode in the sky, we see various colors. The reason that we are seeing those various colors, ladies and gentlemen, is because electrons are moving from one place to another. That is a redox reaction. And when they move, they give off light. And depending on where they move from and to in atoms, they give off different colors of light. Now, most of you had physical science when you were a freshman. Well, if you remember in freshman physical science, we did a lab activity where we burned sticks in a Bunsen burner, and they gave off different colors of light. That is that same idea. The electrons are moving from one place to another, giving off energy, giving off different colors of light, and the different colors were depending on what elements were in there. The same is true with fireworks. Okay, give me another example.
Zinc and
What about it? That's your whole example, zinc and copper?
They ionize, and the copper floats to the surface of the zinc, and it's just a copper metal. I just looked it up because I couldn't find a good example.
Okay. Okay.
Another one is photosynthesis.
Okay, photosynthesis is a redox reaction. There are electrons moving from one place to another in a photosynthesis reaction. Okay? Okay, Zoe, what else you got?
Burning of the wood in a fireplace.
Said the burning of the wood in the fireplace. Again, giving off light, giving off energy. Yeah, okay, go ahead, Victoria.
Iron combines with oxygen to form rust or iron oxide.
One of the most common reactions that happens around us all the time, ladies and gentlemen. Metal rust, iron rust. That is actually a redox reaction. Okay? Other ones.
Or PB0, lead oxide, and hydrogen, and lead, and water.
Okay? Well, here's the thing, ladies and gentlemen. Iron rust, copper, silver, other metals tarnished, those are all redox reactions. All of them. Anytime a metal reacts with oxygen. Ethan.
I have one more.
Okay, well, I called on you. I was hoping you would give it to me instead of just... I figured you had at least one when you raised your hand.
Yes. Hydrogen and fluorine.
Okay, what is that used in?
I don't know what it's used in. I don't know what the reaction is, though.
Okay, what's the reaction?
The hydrogen is oxidized and loses 2 electrons, so each hydrogen becomes positive.
So what does it start out as? What does it become?
It becomes hydrogen fluoride.
And what does it start out as?
Hydrogen and fluorine.
Okay. So again, ladies and gentlemen, when you look these things up, again, I appreciate you finding them. But what I was hoping is that you would give me some things that are very common. So like the rusting is a great example of that. Like Zoe said, your first one, Zoe, what was it again? I'm sorry.
Fireworks.
What? Fireworks. Those are things that we commonly see, okay? You are describing a reaction that is a redox reaction, but I guess what I was hoping is it would have come in some context where, hey, this stuff that is in your home reacts with this and becomes something like this. That's what I was kind of hoping
Well,
for.
I have placing a piece of copper wire in a I don't know how it is, something solution of the Ag plus iron.
Ag plus iron.
It's gold and iron.
The bottom.
Okay. All right. Do you remember, ladies and gentlemen? Oh man, now we're going to make you remember some things. You remember the metal reactivity lab we did in the first trimester?
Yes. Yeah.
Where we put the metals in, we put zinc, we put copper, we put magnesium, and then we put solutions in it in those little well plates.
Yep.
And some of them reacted and some of them did not.
Ah.
Every one of those reactions that we saw in there was a redox reaction. Every one of those where they react, and that's what you were just describing, Victoria, is a redox reaction. Here's another one for you, ladies and gentlemen. Every battery in the world is a redox reaction. The reaction that makes a battery work, ladies and gentlemen, is redox. Reduction and oxidation. Okay? Every single one of them. Yeah.
Breathalyzers?
Breathalyzers are also a redox reaction. Right?
And
So-
some medicine.
What's that?
And some medicine.
Yes. Yeah. There are a lot of redox reactions around us in the everyday world, ladies and gentlemen. A lot of them. Matter of fact, most of the reactions that we have talked about in this class have been redox reactions. A few are not, and we will get into talking about that. But most have been redox reactions. All right. So let's take a look a little bit closer at what redox is, ladies and gentlemen. Get on the right screen here. All right. So there are 4 terms here. Reduction, oxidation, oxidation number, and a half reaction. Okay. Now, first of all, we've been saying this redox. Redox is an abbreviation, ladies and gentlemen. It is an abbreviation of a reduction oxidation reaction. And these are 2 opposite reactions. Okay? They're 2 opposite reactions. So when we look at our terms over here, number assigned to an atom in a polyatomic ion or molecular compound based on the apparent charge of the atom upon a complete electron transfer. Wow! Holy crap. But which definition do you think that's for up here? Which term? These 4 terms, those are the definitions. That first one, which do you think it goes for?
Oxidation number.
Good. Why?
Because numbers.
That's number assigned. So it's going to be an oxidation number. Okay. So the part of a reaction that involves only reduction or oxidation. Which one do you think that is? Now remember, it says the part of a reaction that involves only oxidation or reduction. So which one can't it be?
Reduction.
It can't be reduction. It also can't be oxidation, which means this has to be a half reaction. If oxidation and reduction go together, each one makes up half of the reaction. Okay? So now we've got these 2, ladies and gentlemen. We've got 2 left. A chemical reaction in which a substance gains electrons, a chemical reaction in which a substance loses electrons. Guess what? That's oxidation and reduction.
Really?
Really. Now, I'm going to give you a way to remember which is which, other than simply memorizing. Go ahead. What?
Can I take a guess of what you're about to say? I think when it loses, it's going to be reduction, because reduction means it's reducing the number, and you're subtracting that number. And oxidation would be when a substance gains electrons, because reduction is the one that loses electrons.
So run that by me again.
Reduction would be the one that loses the electrons, because reduction means that it's losing something. And oxidation would be the one that gains electrons, because reductions loses one.
Good. 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 You're absolutely totally backwards.
No.
Uh-huh.
Oh, I feel so stupid right now.
Now, your logic was good logic. And I understand what you're saying. Reduction, you would think you're losing something, right?
Mhm.
But if you gain an electron, what happens to your charge?
It becomes negative.
Which means it's getting what?
Smaller.
Or reducing. You were thinking about the wrong thing. You had the right idea. Reduction is when you are becoming more negative. You are reducing your charge. Which means oxidation is when you are losing electrons. Losing electrons. The oxidation number was the number assigned to an atom or a polyatomic ion or molecular compound based on the apparent charge of the atom. We've already talked about this, ladies and gentlemen. I gave it a different name for you. We'll talk about that in just one second. And finally, half reaction is the part of the reaction that involves only oxidation or reduction. Okay, now that Ethan has shared his stuff with us, I'm going to share mine with you. There is a way that you can remember oxidation and reduction. And here it is, ladies and gentlemen. Leo, the lion, goes grr. Leo, the lion, goes grr. Leo loses electrons, oxidation. The lion goes grr, gains electrons, reduction. That phrase can help you remember which is which, ladies and gentlemen. So when you gain electrons, you are being reduced. When you lose electrons, you are being oxidized. Leo the lion goes grr. Now the other one that I have heard, ladies and gentlemen, people use is oil rig. Oil rig. O-I-L-R-I-G. Oxidation is losing, reduction is gaining. What are you losing? Electrons. So either one of those two phrases will help keep things straight for you. You want to type that in on your chart somewhere, go ahead. You want to write that on the top of a periodic table somewhere, go ahead. But it will help you keep straight which is which. Okay? Losing electrons is oxidation. Gaining electrons is reduction. Okay? Leo the lion goes grr. Oil rig, any one of them will help.
Can you repeat what the Leo the lion one?
Loses electrons, oxidation.
Mister, can you write on the board?
Sure. You guys can't get this from me just saying it?
No.
All right.
The other lion goes grr. Yes.
I'll probably like probably be pondering about it.
Loses electrons is oxidation. That's where the Leo comes in. Gains electrons is reduction. That's where the grr comes in. Either one, ladies and gentlemen. Either one will get you to where you need to be. Now, this is two parts. Part number one is you have to know what oxidation and reduction are. Part number two is you need to recognize which is happening in a chemical reaction. But if you recognize what happens in a chemical reaction, but you don't know if you're gaining electrons, if it's oxidation or reduction, it's not going to help you. So this is the first step, ladies and gentlemen. The first step is figuring out which one is which. In a day, tomorrow, we'll show you how you can recognize what is gaining and what is losing electrons in a reaction. Okay? We could show you that. But again, if you don't know that when you're losing them, it's oxidation, and when you're gaining them, it's reduction, it isn't going to do you any good if you could say, okay, that's the one that became more positive, that's the one that became more negative. Because again, if you can't keep this straight, even if you got it, you're only got a 50-50 chance of getting it right. Does that make sense? Wonderful, wonderful, wonderful. Sorry. Does anyone need more time with this? We're good? Okay. You know, thinking back, Victoria, it probably was a good idea. I wrote it down for you. Thank you. Okay. All right. So a little bit more vocabulary, ladies and gentlemen. There is a reducing agent, an oxidizing agent, and a redox reaction. Okay, which one of these is a redox reaction?
I think redox reaction is the first one.
Good. Okay, you are absolutely correct. By the way, redox is just a shortened version of reduction and oxidation. So if you see it and the O is capitalized, they do that to tell you that that's the second half of it. They didn't just suddenly decide to capitalize letters in a word. Okay? Now, what is reduction again when you're doing what? Gaining electrons is reduction, correct? Okay. Well, a reducing agent is another name for any substance that is oxidized. So if something loses electrons, it's also called a reducing agent. And let me explain why. By losing electrons, something else has to gain, and gaining is which one? I understand they're gaining electrons. Which one is it? Oxidation or reduction when you gain electrons?
Reduction.
It is reduction. So the substance that loses electrons or is oxidized is also sometimes called a reducing agent because it causes the other thing to be reduced. Okay? So by oxidizing, I cause something else to be reduced. By me losing an electron, Jimena gains an electron. She gets reduced. Okay? That's what we mean. Now, I don't actually physically lose an electron. She doesn't physically gain one. That's just an example. But the two have to go together, which means that an oxidizing agent, oops, wrong button, is a name for any substance that is reduced. So by Jimena being reduced, that makes her an oxidizing agent because I had to be oxidized. Make sense? Okay. So they're the opposite of which one is in the name. So the reducing agent is what is actually oxidized, and the oxidizing agent is what is actually reduced.
So they're basically just like what?
Correct. Very good way to think about it. Okay? And then a redox reaction is a chemical process by which electrons are transferred from one substance to another. Okay? From one to another. Now, here's what I will tell you. None of this that we talked about today is on tomorrow's quiz. None of it. That wouldn't be fair. I don't give you information the day before a quiz and put it on that quiz, just so you know. So the properties, the periodic table, the groups and periods, the metal, non-metal, metalloid, the properties of a metal, the properties of a non-metal, those are the things that's going to be on your quiz tomorrow. Fair enough?
Yes, sir.
Questions? All right. On tomorrow, ladies and gentlemen, we will start looking at actual chemical reactions and trying to show you how you can recognize what is oxidized and reduced. Okay? Because then the idea is on Monday, we'll do a lab activity where we oxidize and reduce some things, and we'll try to figure out what's what. Fair enough?
Yes, sir.
Questions? Now, you've got about 15 minutes left to the hour, ladies and gentlemen. There is a Quizlet online for you that you can go to. It is in Google Classroom, ladies and gentlemen. Right here, the Quizlet for review for the periodic table first quiz. Here's the Quizlet that comes up. Okay? Again, some different things that you can do. You can use the flashcards. You can take the test. You can learn whatever you want, ladies and gentlemen.
But you can only take the test once.
Is that all it'll let you do?
Yes.
Okay, can you close it out and go back to it a second time?
No.
Okay, then here's what I would tell you to do. You know how to bring up an incognito window in Windows? Or in Chrome?
No.
You've never heard of that?
No.
No.
Yeah, it was like.
So, okay, you can copy this address, Control C. Over here, these three dots, ladies and gentlemen, you can bring up a new, what is called incognito window. And now when you do it, it won't track that you have been on the site before. So incognito means it doesn't track or give your information to the site.
I don't think it
So
was
now
on.
you could go to it, now you could test again and again and again if you wanted to.
I don't think
That
it
would be
was-
a way around that.
It blocked it for us.
Yeah, it's like.
Incognito windows?
Yeah, they blocked it for us.
All right, then I guess you're going to have to go back to doing it the old-fashioned way. Sorry.
I wonder why.
You only get to take the test once then. But the flashcards are there. The games are there. And to me, rather than do the test, I like the match game, ladies and gentlemen. Okay?
Same.
So again, you're matching them. It's timing you. You see how long it takes. And because there are a lot of terms here, more than you're seeing here, you can do the match game over and over again because it'll bring in different terms the second time. So, questions? All right, ladies and gentlemen, that's all I got for you today. Please use your time wisely. If you have questions, be more than happy to answer them for you, ladies and gentlemen. Otherwise,